power. Okay? Another thing in optimization is that, which this is why I really like the 206 course. Everybody should take. This constraint, in fact, if I want to write it, this should be greater than or equal. My left should be greater than or equal to the width. I don't want to fall down. Okay? But you know, if you take any optimization course, and you know a little bit from this course, that dealing with inequality constraints is a bit harder than equality constraints. Why? Because equality constraints, we know how to treat them very well. Just add the Lagrangian times the constraint and we're done. But inequality constraints, we don't know. We have to try two things. Whether it's greater than or equal. These are two different situations. So you basically you're going to solve the problem twice. Okay? So it will be better if you, from the beginning, realize that, oh, you know what, for sure my constraint will be equality. And this has to come from the physics of the problem, so it urges you to understand your physics better. What do you think here? Will my left constraint be equality constraint, i.e. what we call active constraint, or inactive constraint? It just will be greater than. In other words, can you achieve less power with higher lift than the weight?
No.
It can't happen, right? It can't happen. You cannot do that. You cannot, because this is your cost. I actually pay my cost to get this guy. So I cannot get this guy with less cost. I cannot get this guy extra with less cost. Or the best I can do is that equality constraint. If I want to generate extra left, for sure I will pay more power, right? So understanding these things will help you treat your problem easily. So up to this point, this is just physics. Somebody is describing you his or her own problem in research, and now you as a mathematician or a good engineer or some guy who got this course, you should be able to solve this problem. Do you see this problem as a calculus operations problem or not?
Yes.
Anybody doesn't see this problem as a calculus operations problem? Can you tell me what's your J? Calculus operations, here's calculus operations. I don't want to see anything. I don't care about any of your physical details. Please provide me with your J and G and I will solve it, right? I don't know anything else. I'm just a pure math guy. Please give me G and G and I will just nail it to the end.
J is P.
So this is one of the very important steps in engineering. It's problem formulation. To formulate your problem such that it can be solved or can be added as one of the homework problems in one of the standard courses. This is your task. What's your J here?
P.
Yeah, can you tell me?
1 over T.
Yeah, so it's 1 over T. I want to minimize this guy, right? Well, 1 over T is constant, Kp is constant. This is actually the variable. So I'll just make my life simple and say it's 5 over cubed Dt, correct? Okay? You can add 1 over T or Kp, it doesn't matter for sure. Subject to what? What's your G?
0 to T, phi dot square T.
This is J of 5. What's your G?
Phi dot square T dt. What? Integral.
Yeah, my G is this constraint, but I'd like to write it as a zero equation. So I have to get my weight in the left-hand side and get it inside the integral. Okay, this is not trivial. So 1 over T doesn't matter. Let's write this here. I'll write it here, okay? So left is 1 over T, integral from 0 to T, KL phi dot square dt minus W is 0. This is your constraint, correct? Okay? This is your constraint. Then I will have like this. So if you do like this, then I divide it by T, I have to multiply it by T. Okay? Then I will get this inside the integral. you get this inside the integral. So I have 1 over t integral from 0 to t KL of phi dot squared minus, here is w, and here is dt is 0. It was wt here, and it will go inside the integral, right? It cannot go inside the integral as is, of course, right? It should go inside the integral such that when you get it outside again, you get the same thing, right? So whatever I have here, it's constant. So when I integrate it with respect to t, I multiply, when I integrate with respect to t between 0 and t, basically I'm multiplying by t. So if you're multiplying by t, I should divide by t when I get it inside. So basically the two t's cancelled, but I just showed you the details. And this is your g constraint. It's the integral of this guy 0. I have 1 over t outside. Again, it can be just ignored. So here is your constraint. It's the integral from 0 to t kl of phi dot squared minus weight dt is 0. Okay? Any question about that? Yes, please.
I am not very sure why you are ignoring the constants, because
What constant?
the kp and t, because are we getting the same result in the end?
Typically what?
Even if we ignore kp and t in the j equation, will we reach the same result in the end, because we are ignoring some values?
Certainly. If you're minimizing, here's the function. F of x is kp over t, right? X cubed. This is basically what I'm doing, right? Will you get the exact same minimum if you're minimizing kp over t times x cubed versus minimizing x cubed only?
Yeah.
Are they equivalent problem? Minimizing x cubed versus minimizing kp over t times x. It's a constant. It's a constant, right?
That's positive.
So it's the same thing here. I cannot do that in the weight equation because it's more involved. Yes, Joseph?
So for your equation for the power, since it's phi dot cubed, does that mean on some parts of the cycle the power is negative?
Yeah.
What does that mean?
So, I mean, will get us to the physics of the problem. We don't want to discuss. We can discuss it afterwards. But I will do something here to prevent that, just for our mathematics.
Okay.
Any questions so far here? This is your objective and this is your constraint, and actually this is a very typical problem. We can just solve it straightforward, and you for sure in one of your homework or final you will have a similar problem on an insect, right? So it's you will given all the details and you will be asked to formulate the problem and write down the necessary conditions. So of course it will not be the same objective. I'll give you other objective. One thing here to prevent what Joseph was describing, and also to make our life easier, well, I'm doing here the this is what we call the downstroke, and then the upstroke. Well, if you're just interested in lifting yourself, there is anything that prevents you from doing symmetric flex, meaning going forward exactly like going backward. There is no privilege for the downstroke versus the upstroke. This is not the case when you say maximizing the forward thrust force, okay, or any other objective. But I just want to go up, so I'm doing this thing to go up. Downstroke is exactly like the upstroke. So we're gonna just focus on the half of the stroke, T over V. I will focus my problem completely on this. So here is my problem formulation. Find this shape function that connects these 2 points between negative phi and positive phi. Okay? Your limits will be between 0 to t over 2, 0 to t over 2. Okay? Any question about that? So we'll solve this problem. Now this is really a standard calculus operations problem. It's an isoperimetric problem. So what's your, how can you solve it? Can you solve it?
Yeah.
Lagrangian, so I have cost and constraint, add your cost plus lambda times constraint, get your augmented cost or the Lagrangian cost. This is the integrand of phi dot cube plus lambda times KL phi dot square minus W dt. And I'm gonna call the new integrand my Lagrangian function. And what is your first order necessary condition?
First variation about that.
The first variation of this guy is 0, which is equivalent from calculus of variation to
d by dt of
d by dt partial L partial what?
phi. Phi dot.
Phi dot. Anybody does understand this? Partial L partial phi dot minus partial L partial what?
Phi.
Phi is 0. And you can do it on your pace, but this is 0, and you're experts on continuing this. You'll get a second order differential equation. If you're interested in solving it, solving it. Of course, in the exam or the homework, I will not ask you to solve it, but you will need to get the equation itself. Any question about this?